present annual future worth. So let's recall from week 1. Remember, we talked about how we had P times 1 plus IN equals F, and that was our simple interest, versus we had P times 1 plus I to the N equals F, and that was our compound. As I stated previously, unless it says simple, you should assume compound. And so even really for the rest of this class, we will be working with compound from now on. So P stands for present value. F stands for future value. And then remember, we did already talk about how A stands for an annuity or some like annual payment. And remember, we said G stood for gradient. So, given one of these letters, given one value, let's say we're given P, we can find any of the other values. Like we did last week, we found F. And there are equations for all of these variables. However, you know, it could be a lot of algebra to work with those equations. They get more and more and more complicated, especially with the gradients, because they're just kind of crazy. So I'm going to show you a different way instead of having to do a bunch of algebra to solve for your unknowns. So we're going to use lookup tables. And like I said, this is in lieu of equations. If you have the book, it is in Appendix C on pages 645 through 674. If you don't, it's posted on Canvas. So if you go open Canvas in the Files section, let's see what I called it. Oh yeah, I just called it Appendix C, CI tables. So it's in there, accessible to you if you don't have the book. You can just look at it online on Canvas, okay? So there's some notation here. Let's say I wrote F/P. Let's say I wrote something like that. What it means, it is read out loud as F given P, meaning I want F given that I already have P. And it's written as this. So you say F given P at some interest rate in a certain amount of years. So again, this is what we want versus this is what we already have. And then you have your interest and your years. So remember, we had an example from week 1 where I asked you to find the future value. I said that the interest rate was 10%. I said you have 3 years and the present value was 1,000. This was an example we were using to compare simple and compound interest. So to use the table, you would say, okay, I want F, I'm given P at a 10% interest rate over 3 years. And in the table, to know where to look, basically this represents the column you're looking at, this represents the page you're on, and this represents the row. So I'm going to show you one time I'll share my screen, but the rest of the time I'm assuming you have this pulled up. So make sure you know where to find it or you have a book. So it looks like this, compound interest tables, okay? And you see these percentages like up on the left-hand side, 1/4%, 0.5%. So you would need to find the right page for 10%. So we're gonna scroll, we'll find 10%. So we're on the right page, you see that, 10%? Okay, so then you've got all these different columns. You're going to look at the column F given P, so that's that first column, F given P. And you're going to look at the row 3. So we've got this number right here, 1.331. Does anyone have questions about this table? Okay, so like I said, we ended up on page 663 in the book, which brought us to a number of 1.331. And this represents your compound interest factor. So all we have to do is multiply by P to get F. And visually, you could think of it this way. We have some number F given P. Think of it as a fraction. If we multiply by P, then the numerator and the denominator cross off. And you are left with F, which is what you want. So to find F, we would just take the present value, $1,000, multiply by our interest factor that we found from the table. And what would we get? Yes, and looking back at your notes, you should notice that that is the same answer that we got before when we were using the equation. So now I have proven to you that you can trust the table. It works. It gives you the same answer, I promise. Okay, so instead of using that F given P equation that we learned last week, you could just go look up the number and multiply by your present value, and then now that's your new future value without having to plug anything into the equation. So what we're saying is, in terms of cash flow diagrams, we went from having $1,000 at year 0, and given that we were offered 10% interest, we changed it to $1,331 in year 3. The key thing here is that these are equivalent values. And what I mean by that is you would be indifferent if I said, do you want $1,000 today? Or do you want $1,331 in year 3? Given that your interest rate is 10%, you would say, meh, it's the same. I don't care. They're equivalent. For an example of present worth, let's say you had an annual payment of $100 for 5 years, and you wanted to know how much that was worth in today's money with an interest rate of 12%. So remember, you can use the table posted on Canvas in the files section. So what do we have? You had an annual payment of $100. So what letter is that?
That's your P?
So you had an annual payment. So P would be a singular payment.
Oh, that's right.
Okay. What letter would it be? A. Yes, Steven's got it in the chat. Sorry, Andre. In the chat, Steven wrote A for annuity. Okay. So we have an A, so that's good. So we'll say we have an A. And what do we want? What do we want to change it to?
Final payout.
E.
So we want it in today's money. So if we wanted an F for final, that would be in like tomorrow's money or the future money. But since we want it in today's money, it would be a P. Okay, so we have an A, we want a P. Okay, so how do we write? Remember, go back to your notes. How do we fill this out? What do we write?
Column page.
Okay, so what's the first thing that we put?
F over P.
So what do we want?
P.
What do we have?
A.
So it's P over A. Okay, what interest rate?
12%.
How many years?
5.
Okay, look that up in the table. What do you get? So go to the page with 12%, go to the column with P over A, and go to the row with 5, and tell me what you get.
$3.605.
Perfect. Okay, so what we're doing is we have an A, and we're going to multiply it by P over A just to get P, right? You can see how those fractions would cross off. So to get P, we're going to take our A, we're going to multiply it by 3.605. What do we get?
$160.50.
$360.50. So what we're saying is we went from having an annual payment from year 1 to year 5 of $100 and knowing that I is 12%, we changed it to one singular payment at the present year of $360.50. So what I want you to notice is that it's not 500, right? You might think at first that it's 500, 100, 5 different times, so it should be 500. But because of time value of money, because of interest, when you bring it back in time, it's actually less. So
this is saying that if we put in 360 now, it would be 500 by then.
No, it would be equivalent to putting in 100 each year. Yeah. Never is it actually worth 500 because even if you said then in year 5, there's interest as well. So it might be more than that, if that makes sense, because there's 12% interest. So because of the time value of money, because each year there's 12% interest, it's never just going to be 100 times 5. So time value of money, P does not equal 500. And then just basic to remind you, the work and the cash flow diagram are required on your homework or your quizzes or your tests. So the same way I show my work in class is what I'm expecting you to show your work on your homework, quizzes, or tests. Now we're going to do an example of annual worth. What if you bought a $10 item and sold it seven years later for $2? with I is equal to 8%. What's the equivalent? Annual value. So if we were to draw the first cash flow diagram of what our situation actually is, we're going to go from year 0 to what year?
7.
Very good. And what are we going to draw on this cash flow diagram?
First thing would be first cost.
All right, we've got $10 at year 0. What else do we have?
Salvage at $2.
Very good, year 7. All right, we are given that we have an 8% interest rate, and we want to convert it to an annual value. How would I draw that? What shape is it?
Would it be a gradient of some sort?
So it's just an annual or an annuity. So what does an annuity look like?
A rectangle?
There you go. So, I mean, it could be a cost or a benefit. I guess technically we don't know yet because we haven't done the calculations. But we're basically saying we want to convert it to one annual payment or something like that. So, whereas in present worth, we went from whatever we had to one initial payment at year 0. In annual worth, we're going to whatever we have to some recurrent payment. So we're going to do annual worth. So for example, I have my negative 10 because it's going down, so that's why it's negative. We want an A, so we want to turn everything into an A for annual worth. What is it right now? What is that $10? What letter?
P.
P. Very good. And what's our interest rate?
8%.
8%.
8%.
Yes. And over how many years?
7.
7. Very good. And then let's see, how about that $2? What should we multiply it by?
The value off the lookup table?
Yes, but how would you label that lookup table? So what do we want? What letter do we want?
We want A, right?
Yes, and what is it?
F.
Very good. What's the interest?
8%.
How many years?
7.
Okay, so go to the lookup table and tell me, what do you get for the first one, A given P, 8%, 7?
0.1740.
That's not what I got. Make sure you look at the right page for 8%. Go to the column A over P. Go to the row 7.
Oh, it's 1.1921.
Perfect. And then how about A given F?
Point 1363.
Okay, try again. Page 8%, column A over F, row 7.
It's 0.1121.
Perfect. Okay, and what do you get when you do that math?
You get negative 1.6968.
All right, so basically negative 1.7. So you would write, all right, the equivalent annual worth is $1.70 cost over 7 years. So instead of buying it for $10 today, selling it for $2 in 7 years, it would be equivalent to making a $1.70 payment every year for 7 years. Question about that?
Yes, can you please go over what the annual worth equals? What's, you wrote 2 lines, -10.
Mm-hmm.
What we have and what we want. What we want
Yes.
is the P.
We actually, for annual worth, we want to change everything to an A. So this first row right here is what we want. And that second, those ones were what we had.
So the calculations -1.70 was just 2 multiplied by 0.1121.
Minus 10 times 0.1921. Yeah, this is all one line of work. I just wrote too big. It's all one equation.
So -10 is our P and 2 is our F.
Yes.
Okay.
And we're changing them both to A. So first is want A given initial, and the second one is want A given final. Yes. Other questions? So before we did present worth, so we wanted P, right? In annual worth, we want A. And so if we do future worth, what do you think? What letter do we want? Very good. So let's do a practice problem for future worth. What if you made $50 in year 1 and $10 more each year thereafter for 9 years with an interest rate of 15%. What's your value at the end of your venture? So drawing the cash flow diagram for what is given. What should I draw?
Year one, up arrow, $50.
Okay. Then what?
It's an annuity all the way to year 7.
Okay. Well, year 9, right?
9, yeah, sorry.
Okay. So that's an annuity of $50. Then what?
The gradient line, $10 per year.
Good. So we've got like a triangle basically, and the slope is $10. So we want to know, given that our interest rate is 15%, how can we convert this to just one single benefit at year 9? That's what we want. So we're going to try and set up our future worth equation. So since 50 is green and it's positive, it's pointing up, it's a positive 50. What do I multiply it by?
F comma P.
So we want F, but what is the 50?
Oh, it's an annuity.
Very good. So F given A, and what's your interest rate?
15.
How many years?
9 of them.
Okay. And then we also have that $10 that is also green pointing up, so it's positive. And what should we multiply it by?
F over G.
Very good. We want F, but it's a G. 15%, 9. Okay, when you go to the lookup tables, what do you get for F given A 15% 9?
16.786.
Good. And what do you get for F given G 15% 9?
I don't see one for F over G.
Yeah, it was a trick question. So
Okay.
torturous, huh? There was no F given G, so you're like, shoot, I can't look it up in the table. So instead, you could kind of piece it together. So instead of F given G, like we don't have F given G. That's not an option in the table. This is a G. We could bring the G back to year 1. So we could say like P given G. And then take it out to future year 9 and do F given P. And basically the combination of those two would give me F given G. If you see, because you can kind of imagine like the numerator and the denominator canceling. So what do you get for that first one? P over G.
$14.755.
And F over P.
3.518.
Okay, and then remember we're multiplying that by 10 still. And so what do you get when you combine everything?
1358.38.
1,358.38. What does that number represent?
Is that the future worth?
Yeah. So instead of making $10 in year one and making $50 in year one and making $10 every year thereafter for 9 years, I could just be paid one payment of $1,358.38 at year 9, and it would be equivalent as long as I know my interest rate's 15%. Questions about that?
We can do this with any combination of them as long as they cancel out to the ones that we want, right?
Yep.
Professor, could you just briefly go back over why you chose P over G and then F over P?
Yes. So F over G is not a column in the book when you're looking at those reference tables. It's not there. So then you kind of have to piece it together. So like Justin was asking, can we use any combination? You could. I just look at it as you kind of look at it as like a numerator and denominator thing where you would want it to cancel out so that it ends up being what you want. The way I looked at it was, well, there is a P over G, right? I have a G. I want to get rid of it. So how do I get rid of it? I can change it to P first. Now it's a present value. And there's an F over P, and I can change that P to an F now. So I've essentially gone from G to F, but just in 2 steps.
Thank you.
Mm-hmm. Other questions? So let's talk about decision making. So let's say you have like several scenarios, or at least 2 scenarios that you're trying to compare and decide which one's better or which one's worse. So of course we would want to maximize benefits or minimize costs. So like, for example, if they were both costs, then we would just minimize the costs and choose the smallest one. If they're both benefits, we would choose the biggest one. And then we want to choose the alternative, of course, that is the most economically attractive. This is at the point where I said, remember I told you to write down those examples when we were practicing the cash flow diagrams. I said, you better save these because we're going to learn how to do the calculations next time, right? So make sure you still have your notes from last time so you can reference those problem statements and those cash flow diagrams that we already drew. So we're going to do an example. We're going to do I think all of the examples we drew those cash flow diagrams for last week. So for example, let's see, this was example 2 from last week. This is the one, let's find it, example 2 from last week. This one right here. So the firm was deciding between 2 machines. One will save $300 a year. The other will save $400 the first year, but will decline $50 per year. Each device costs $1,000, has a useful life of 5 years. And the assignment last week was just to draw the cash flow diagram. And this week, we are going to take our cash flow diagrams that we already drew. We'll reference them. And we will do some calculations. Okay, let's label this like A and B. So for A, the present worth for A, someone help me out. How should I calculate the present worth for A? Sure, where do you want me to scroll up? Was it from this problem, the future worth? Decision making. Okay, here you go. Okay, so these are the cash flow diagrams you should already have. You should already have the problem statement from before. How should I start calculating the present worth? What should I do?
You should do P over A
Times what?
times
The negative 1,000.
Okay, let's just work left to right and then we'll talk about it. So we have a negative 1,000. What letter is the negative 1,000?
A.
So the negative 1,000, that singular red arrow, is a present value. It is a P, and we want a P. So we don't really need to multiply it by anything, because if you could think about it, it's kind of like P over P. Really, that just like crosses off, ends up being 1, right? So we don't really need any conversion because it is a P already, and we want P because we're doing present worth. Okay, and then now let's do the 300. So we have the 300. It's positive because it's green, pointing up. What letter is the 300?
That one's A.
That one's an A. And what do we want?
P.
We want a P. So it's P over A. 18%, because I did not give that to you, but we're going to use 18%. I is 18%, so write that down. And over 5 years. So what do you get when you look that number up in the table?
$3.127.
Great. What do you get when you plug it all in?
Negative 61.9.
Yeah, $61.90, negative $61.90. Questions about how we got that?
Quick question. I think I missed P over P for the negative 1,000.
Mm-hmm.
That's why it cancels out. How? Oh, okay. I see. Never mind.
Yeah, it's already a P and we want a P, so we don't need to convert it at all. Other questions?
Yes, maybe it's going to take us back, but are you using, like when we started the lecture on the 3rd, are you using this formula, the F over P times I times N, not times I, but so you're basically, the information you're always converting in what we have, what we want, the percentage and the number of years.
Mm-hmm.
And in this case, why is there's kind of two equations? Well, not two equations. There's one for the growth and the other one for the losses, right? And then we combine them together to get the final worth.
Yeah, so each arrow that you see on there, you just treat separately. So you just you step your way along the way. So you've got the negative 1,000. You think to yourself, what is it? What do I want? So it's a P. I want a P. Good. I'm already in good shape. So you have that, and it's negative because it's red. It's pointing down. And then you've got the 300. What is it? It's an A. What do I want? I want a P because I'm doing present worth. So I'm going to do P over A. So using these reference tables, Andre, is in lieu of those equations that I gave you at the beginning where it was like P equals or F equals whatever, all the algebra you had to do before. Yeah. Now you don't have to do the algebra because you can just use these tables.
Yeah. So in this problem, we said P present worth equals, so automatically we see that we're looking for present value.
Yes.
And then we look at the growth and we say, what's the present value? And present value means all the way at the end of the 5 years?
No, present means today.
Okay.
So present means bring it back to year 0. If it's at year 0, good. If it's not at year 0, you have to convert it and bring it back to year 0.
And what we're looking, what's the negative $61? What is it?
What does it represent? It represents, instead of that cash flow diagram that you see for part A, instead of having a one-time payment at year 0 and then a yearly payment of a yearly benefit of 300, year 1, 2, 3, 4, 5, it's equivalent to say just today make a one-time payment of $61.90, and you're doing the exact same thing.
Okay, thank you.
Mm-hmm. The original problem was from the notes that we took when we were just doing cash flow diagrams. We were just practicing cash flow diagrams. So that was, it was example 2 from the cash flow diagram notes that we took. I think we did like 4 examples. And in that example, I had just asked you to draw the cash flow diagram. And in this case, I added in what the I was, which was 18%, in order for us to now do calculations. I didn't forget to give it to you because I told you that when we took notes, you should have written it down because I said we were going to do calculations on those notes the following week. So you should just be able to reference your own notes. Okay, other questions before we do B?
So that's basically like the net cost at the end is what?
At the beginning, at year 0.
Okay.
Yes, at present day.
All right.
And before we would do like a wiggly thing and we would do another cash flow diagram. Do we still need to do that, or we just jump into calculations?
Oh, those were just visuals for you to understand the difference. So you don't have to do that. So for present worth converts everything to year 0. That's what that second diagram was showing you. Annual worth converts everything, spreads it out over each year. And future worth just puts it at the final year. Okay, so that was just a visual to show you what we were converting it to. But in terms of what's required, like on your homework, you would need to draw the original cash flow diagram, and then you could go straight to the calculations.
Thank you.
Mm-hmm. Other questions? Okay, so B. Now, before we start doing these calculations, I want to point something out. When we learned about gradients, remember, we said it could look like this, like it could be going up like this, right? And even if maybe this is also like an annuity underneath it, right? But it starts kind of at 0 and it increases going up. Yes, or a gradient could be going down, like it could start at 0 and go down this way as a cost, right? And it could start at 0, or even if it had like some also annual payment you had. But essentially it starts at 0 and then it increases, right? Whenever we learned about gradients, that's always what it did. Like when you're reading left to right, it always started at the smallest value and then increased that way, whether it's positive or negative. The problem with part B is that that's not what it does. You see, it starts at the highest value and goes down. And that's an issue because it looks like a gradient because it's a line, but the definition of a gradient is that it starts at 0 and increases, not starts at the top and goes down. Okay, so the way to handle that is to sort of think of it as, instead of, see how we had an annuity and then we added on top a gradient? Instead of that, we're going to look at it as a big annuity at the highest point. Okay, and if we subtract out a gradient, if you think of like looking at this shape, if we were subtracting out that, then do you see how if you were to flip it and invert it, it would be the proper shape? We would keep just this stuff. Okay, and essentially now that's the right shape that we want. So in terms of the math, we're going to go to the highest point, the annuity being 400, and then we will subtract out the gradient of, what was the slope, 50? So starting with the $1,000 arrow right there, when we're doing present worth, it is a P and we want a P. So we don't have to do anything but just make sure we account for it in the equation. We don't have to convert it. And then we're going to add that 400. And what letter do we want it to be?
P.
What letter is it?
A.
Very good. What's the percent?
18.
And how many years?
5.
Very good. And now we are going to subtract that gradient of 50. So what letter do we want?
P,
What letter is it?
G,
18% and 5. So P over A, 18%, 5, we already did that. That was 3.127. And P over G, 18%, 5. What do you get when you look that up?
I don't think we can look that one up. We have to split it up.
5.231.
You can look it up. The only one that I've seen that you can't look up is the one we ran into is F over G. And that's just because, I don't know why, they could have done it, but instead they just figured, oh, you can piece it together yourself. But this one, there is a column there. And so it was 5.231. So if you add all that up, what do you get?
Negative 1075.
Negative 1075. What does that number represent?
Present worth.
Yeah. So it means that instead of this crazy cash flow diagram that we had, we could just draw one arrow at year 0, down 1075, and it would be equivalent. So based on this, if your boss said, well, which option should we choose? Should we choose option A or option B? What would you tell them?
E.
Option B.
Very good. So we're going to choose option B, and what would your reasoning be?
It's cheaper.
Cost.
Yes, it's cheaper, and you would right to minimize costs. Questions about that? Is present worth always a cost? No. Present worth is just whatever you bring it back to at year zero, whatever it ends up being. So you could be a benefit. We found an equivalent number, 6190 for A, an equivalent number 1075 for B. They're both costs at year zero, and we're comparing which one's the better option to choose.
Can you walk through again the present worth negative 1000? I don't understand why we have that there and not on the bottom, since it's a negative, not on the second, not when we're on our losses.
You don't have to separate your losses and your benefits. It's all going into one equation anyway. You're adding and subtracting. So I'm just reading left to right.
I see.
Yeah. Other questions? So is that true for all of these? Yeah, for all of them, they can end up being costs or benefits, depending on just whatever the math comes out to be, whether your answer is negative or positive. And so you have to figure both of them out and then compare them. So let's try another example. So go back to your notes from last week and look at example 3. Okay, so we're going to do example 3 from last week. And last time, because we were just drawing the cash flow diagrams, I didn't give you the interest rate. This time I will. I is 7%. So we're going to go back to our notes, example 3 from last week. Okay, it was this one, scale A and scale B. We drew those cash flow diagrams already. So you should have that in your notes. You can reference it. Scale A and scale B. So let's practice. Last time we just did present worth. Let's practice with annual worth this time. So for scale A, we're going to try and do annual worth. Okay, so we'll just work our way left to right. So that 2,000, first of all, is it positive or negative?
Negative.
So we're going to write negative 2,000. What letter is the 2,000?
Present.
But what letter do we want?
A, annuity.
Very good. Because we're doing annual worth this time, we want A and we have a P, so we have to convert it. And our interest rate was given as 7%, and we're converting this over 6 years. Okay, that 450, is that positive or negative?
Positive.
Positive 450, and what do we multiply that by?
Will we leave it alone since it's already like an annual payment? It's an annuity already.
Very good. It's already an A. We want an A. It's already an A. We don't have to convert it at all. All right. How about that 100? Is that positive or negative?
Positive.
Okay. And what should we multiply it by?
A over F, and then
Very
the
good.
interest in the years.
Perfect. A, given that we already have F, we want A, we have F, 7%, 6. So when you look up a given P, 7% 6, what do you get?
.1856.
Make sure you're on the right page. Go to page with 7%, column A over P, row 6.
0.2098.
Yes. All right, and how about A over F?
0.1398.
Yes. Question about how we got that. Okay, now just add it all together. Combine everything. What do you get?
$44.38.
Very good. Positive $44.38. What does that number represent?
Your annual payment that you pay to get the total over the 6 years.
So it is an annuity, but it's positive. So it would actually be an annual benefit coming to you over 6 years. In lieu of that entire cash flow diagram, it can be replaced by one annuity of the value of positive 44.38. Okay, so let's try option B, annual worth. Option B, what should I do?
Real quick for that 44.38. So you would get that 44.38 benefit for the 6 years, right?
Yes, every year. So for B, what should we do?
AW equals negative 3,000 times A over P, 7% at 6 years.
Okay.
And then plus 600.
Okay.
And then plus 700 A over F, 7% 6 years.
Why does the 600 not get multiplied by anything?
It is also already an annual value.
Very good. We want an A. It's already an A. What do you get when you plug it all in?
$68.46.
$68.46. What does that number mean?
That's the benefit to you every year.
Every year, instead of what you see in that cash flow diagram, you could change it to one rectangle of a positive 68.46. So what conclusion should you make?
Option B.
Why?
Maximizes the benefits.
Very good. Choose option B to maximize benefits. And now we're going to go over example 4, where we're going to do future worth. So this is the example from the other lecture where we were talking about a brick versus a wood deck. Okay, so we're going to do example 4. From last lecture. And remember, I didn't give you an I because we were just drawing the cash flow diagram. So in this case, I'll give you an I of 2%. So finding example 4, that was the one about the brick versus the wood deck. So you should have this in your notes, but I will at least copy over the cash flow diagrams that we drew. So here it is, the brick versus the deck. Remember, we had to line them up and make them both 30 years. One had a 30-year lifespan and the other one had a 10-year lifespan, and we had to make sure they lined up. Remember that? Whoops. Really? Okay. So these were the cash flow diagrams that we came up with from that brick versus wood deck. Okay, so this was the brick, and this was the wood. And we're trying to decide between which option we should choose. And in this case, we're going to practice future worth. Okay, so we want to bring everything out to the future. So what could be helpful for a lot of you is to label what we have so far. So looking at that brick, what is the 1800? What letter is that? P, A, G, or F?
P.
How about the 5?
A.
All right, how about the 450?
P.
Okay, each time. The 20?
A.
Okay, so we want F though because we're doing future worth. So for example, we have negative 1800, negative because it's pointing down, multiplied by what? What do we want?
We want F given P, right?
Very good. 2%, 30 years. Okay, and then we have that $5. We've got to put negative because it's pointing down. And what do we multiply that by?
Yeah. A. Or sorry, we want F given A.
Very good. What do you get when you look up F given P? 2%, 30?
$1.811.
Perfect. And how about F given A, 2%, 30?
$40.568.
Questions about how we found those numbers? What do you get when you add that all up? The table is in Canvas in the Files section, and it should say like Appendix C tables or something like that. Interest tables.
Professor, negative 1800, that's the present worth.
Negative 1800 was our first cost.
First cost. And I don't get the 5. Where we got the negative 5?
The 5 was our annual. You see the cash flow diagram?
Yeah.
Yeah, that was from the previous lecture when we drew out the cash flow diagrams from brick and wood. So go back to your old lecture when we were just practicing drawing cash flow diagrams. That's the problem statement. And the problem statement said that the maintenance, operations and maintenance costs $5 per year, every year for 30 years.
Okay, so we're just doing this first brick cash flow diagram, right?
Yes.
Thank you.
Uh-huh. Did anyone get the total?
The answer is a negative 3,462.64.
Okay, so that is what the brick would cost us in future dollars total. Okay, and now let's do the wood. Future worth, help me out. What should I do?
Start with the 450
Okay,
and then multiply it by we want F given P, and then 2%, and then 30.
what do we do with the next 450?
The same thing.
How is it different?
Is it going to be 20 years instead?
Very good, because we only need to move it by 20 years to get it over to your 30. And how about the other 450?
10 years.
Mm-hmm. And how about the 20?
That would be F given A, and then 2%, and then 30.
Great. F given A 2%, 30, we already looked up 40.568. F given P 2%, 30, we already looked up 1.811. What do you get for F given P 2%, 20? So Jamar, you cannot add the 450s together because they're happening at different times, right? They're not all happening at once. So because of time value of money, because of the interest rate, you can't just say, oh, 450 times 3, right? Because they're each happening at different years. F given P 2%, 20, what do you get?
1.486.
F given P 2%, 10, what do you get?
1.219.
And what do you get for the total?
Negative 2,843 and 56.56.
Why are both our answers negative?
Because we aren't making revenue off the deck.
Very good. Our entire cash flow diagram, everything was pointing down. Okay, which deck should we pick, brick or wood?
The wood deck.
Very good. So you would say, therefore, choose wood option. Why?
To minimize cost.
Very good. To minimize costs. Okay, so it's interesting because, you know, sometimes if you were looking to make an improvement on your home and you're asking your parents for some advice and they'd say, take my advice, the brick will last longer, do the brick deck. And you can say, I did the calculations, even if I have to replace the wood deck 3 times, I'm still paying less than the brick deck. So I'm going to go with the wood deck. You know, you can consider other things such as it's annoying to have to rip out the deck and replace it, right? And what is that worth to you? Are you willing to spend the extra to not have to replace it? However, it is cheaper. more economically advantageous. So these are all called ranking processes because all we're doing is we're getting a number and then we're ranking them. Which one's better, which one's worse, right? And they'll all get you the same conclusion, whether we do present worth, annual worth, or future worth, you'll all get the same conclusion, okay? You will, no matter if we had done present, annual, or future, we still would have chosen the would. Of course, our number is different because it represents something different, right? Today's money spread out over the years or future money. But regardless, the ranking of them will not change. Okay, so all of them will give us the same answer. However, the difference is just kind of where they consolidate. Where are you moving everything to year zero? Are you spreading it all out? Or are you putting it at the final year? So you might want to write that down, that each ranking process will get you the same conclusion no matter what. It's just what's different in them is kind of where you consolidate the money, where you put it. Are you putting it at year zero? Are you spreading it out over the years? Or are you putting it at some future time?
And by each ranking process, you mean either like future, present, or annual?
Yes. Present, annual, and future worth are all ranking processes because we just get a number, an individual number for each option, and then we rank them. Which one's higher, which one's lower. Of course, your interest rate has to be the same to be comparing apples to apples, right? But as long as your I is the same, then each present worth, annual, future worth will give you the same conclusion. They would all tell you to choose the wood deck. They would just tell you in a different way. They would compare today's money, or they would compare a spread out payment, or they would compare future money. But they would all tell you to choose wood. Now, my question to you is, which procedure makes the most sense? Present, annual, future. To you. What makes the most sense?
Annual.
Why?
Because you can, I guess, budget.
Yeah, that's a really good point, Andre. For example, if you were to buy a house, right? You're really just looking at that annual payment, or it's a monthly payment or whatever it might be, that regular payment or a car payment. You're looking at, can I afford this regular payment, right? So that does make sense, annual worth. Anyone else have a different opinion?
I would almost say future.
Okay, why?
Just because, like what the final is going to be.
Okay. For example, if you're saving up, to pay for something in the future, then that would tell you like how much money you need in your bank account, by that time. Yeah, that's a good point. To me, present worth makes the most sense because I know what today's money is worth. Like $100 today, I understand what that will buy me versus $100 in 10 years. I have no idea what that will buy me, So to me, present worth can make sense as well. So I think it depends on the scenario. And if the problem statement doesn't tell you which one to do, then you can do whichever one you want. Okay.
Just like, because like the prices for these things could fluctuate and then everything could change after a couple of years.
Mm-hmm. Yeah. Good point.